Hello everyone, welcome once again. In previous class we see the integration of the form that integration of 1 upon x square plus bx plus c and 1 upon root x square plus bx plus c. So in this type of integration we have to use the proper steps and some examples of this type are also seen in the previous lecture, right? Now see the next type of integration, that is integration of the form 1 upon a sin square x plus b cos square x plus c dx. So in this type of integration we have to again follow the some steps. First one is we have to divide numerator and denominator by cos square x or sin square x, right? Then mostly if we go with one from these two, then also answer is obtained. मतलब अगर हमने दोनों में से किसी एक से भी डिवाइड करके सॉल्व किया हर सभी एग्जांपल्स को, तो भी आंसर हमको मिल सकता है. इन डिनोमिनेटर, if first step is this, divide the denominator by cos square or sin square, then replace x square by 1 plus tan square or cos square by 1 plus cot square in denominator, right? This is the second step. In third step we have to put tan x equals to t or cot x equals to t in the given integration, which is obtained after these two steps. Then we got this type of integration, that 1 upon at square plus bt plus c, and in this integration we use the standard steps as seen in the last lecture, right? So this is the actually one of the type of the integration. Okay, so we see some examples of this type, and before that we see another type of integration. Then we see the examples of the both types. See that this is the next type of integration again, that 1 upon a sin x plus b cos x plus c. If the integration is in this form where abc is constant, so we have to put tan x by 2 equals to t. This is the standard substitution we have to use to solve the integration of this type. So put tan x by 2 equals to t. For dx it is sec square x by 2 into 1 by 2 dx equals to dt. The dx is up 2 upon sec square x by 2 dt, that is 2 upon 1 plus tan square x by 2 dt, that is twice dt upon 1 plus t square, because tan x by 2 is t, right? So this should be the substitution for dx. Tan x by 2 is t, dx is twice dt upon 1 plus t square, and for sin x it is 2. We know that sin x is 2 tan x by 2 upon 1 plus tan square x by 2, so it is twice t upon 1 plus t square. This is the substitution for sin x. And for cos x it is 1 minus t square upon 1 plus t square, because cos x is 1 minus tan square upon 1 plus tan square, right? So these are the standard substitutions we have to use to evaluate the integration of this type. After substitution, after and simplifying, we got the same type of integration, that is 1 upon ax square plus bx plus c. So we have to proceed the steps of that type, right? So this is the actually second type of integration. The examples of this type is also we see. Before that, one of the type of integration which is very similar to this one is this. See this: if instead of x here twice x, and instead of here also twice x, so if integration of the type 1 upon a sin 2x plus b cos 2x plus c, then substitution is slightly different, that here dx is 1 upon 1 plus t square dt, that is dt upon 1 plus t square, and see here is dx is twice dt upon 1 plus t square. But only difference is this. And substitution for sin 2x is twice t upon 1 plus t square dt, and for cos twice x is 1 minus t square upon 1 plus t square, right? These are the substitutions in the this type of integration, that is 1 upon a sin 2x plus b cos 2x plus c, right? Now after substitution again we got the this integral reduced to the form of this 1 upon ax square plus bx plus c, and we use the standard formula to evaluate such integration, right? Now we see the examples depending on these three types. See this one, that integration of 1 upon 2 minus 3 sin 2x dx. right? If we see, this is of the form 1 upon a plus b sine 2x dx, right? So here, as we know the standard steps, so according to the standard steps, we have to put tan x equals to t. Substitution for dx is 1 upon 1 plus t square dt, that is dt upon 1 plus t square, and for sine 2x it is 2 upon 1 plus t square, right? So these are the substitutions put in the given integral. See what we get, dx is 1 upon 1 plus t square dt, and upon 2 minus 3, and sine 2x is 2 upon 1 plus t square, right? So simplify this, what we get, see here, 1 into this numerator as it is, here cross multiply, so 2 into 1 plus t square, that is 2 into 1 plus t square minus 3 into uh, twice t upon 1 plus t square, right? Then here actually t, यहाँ t चाहिए होगा, okay? So twice t dt, then 1 plus t square 1 plus t square cancel, 1 upon 2 into 1 2 plus 2 into t square twice t square minus 3 into 2 6t, okay? It equals to 1 upon 2, take common, so what we get, t square minus thrice t plus 1, right? So this 1 by 2 is constant, take outside the integral, and if we see, this integral 1 upon x, this integration is in the form of 1 upon x square plus bx plus c. So use the steps involving in that type, that make the coefficient of x square as 1, so that is already 1 after taking 2 common. Then that divide the coefficient of t by 2, so what we get after divide, or simply half coefficient of t whole square, so half coefficient of t is minus 3 whole square is 9 by 4, add and subtract this 9 by 4 in the denominator of the function, so what we get, t square minus thrice t plus 9 by 4 minus 9 by 4 plus 1, right? So then solve, simplify that term, that 1 upon t square minus thrice t plus 9 by 4 minus 5 by 4, how 5 by 4 comes, that is minus 9 by 4 plus 1, that is 5 by minus 5 by 4. Now this bracket terms is the perfect square of t minus 3 by 2 whole square, right? And 5 by 4 in the square form is root 5 by 2 whole square, right? Now if we see this step, we got as a form of 1 upon integration of 1 upon x square plus minus a square. So integration of 1 upon x square minus a square is what, 1 upon twice a log of x minus a upon x plus a, right? So it is 1 upon twice a means root 5 by 2 log of x means t minus 3 by 2 minus a means root 5 by 2 upon t minus 3 by 2 plus root 5 by 2 plus c. Okay, then this 2 cancel, and here 1 upon 2 root 5, and log of, here cross multiplication is there, so t into 2 twice t minus 3 minus root 5 by 2 upon twice t minus 3 plus root 5 by 2, 2 cancel, so here is not considered that. So now finally resubstitute the value of t. We know that we consider t as a 10x, so it is 1 upon 2 root 5 log 2 tan x minus 3 minus root 5 upon 2 tan x minus 3 plus root 5 plus c. This should be the final answer here, right? So in this type of integration we have to solve like this. See again, after substitution, simplification, then this is the standard form, follow the steps involving that in this form, and then use the standard formula to evaluate the integration. Very easy process, and the very easy steps are there, right? So try to understand, and try to complete the remaining examples of this type also, right? Now see the example of the another type, that is integration of 1 upon a sin x plus b cos x, that type, right? So in that this here 1 upon sin x minus root 3 cos x, right? So here we have to put tan x by 2 equals to t, right? So we have to put tan x by 2 equals to t. What is dx then? Dx is nothing but actually sec square x by 2 into 1 by 2 dx equals to dt, right? So dx is what, twice sec square x by 2, right? So sin x is what, we know sin x. See what is the substitution of sin x, see in this example, and try to put sin x is twice dt upon 1 plus t square, right? So here also we put sin x is twice dt upon 1 plus t square, and cos x is 1 minus t square upon 1 plus t square, right? So try to complete this activity in this type, right? And find the answer. Okay, then this is alternative method for that, already solved in your textbook. Okay, then next is what? See, now it is a another type of the integration. See this example, that integration of 1 upon 3 plus 2 sin square x plus 5 cos square x dx. So see, I is a given integral, and as a step involving that type, first step is divide numerator and denominator by cos square x, right? So 1 upon cos square and upon 3 plus 2 sin square plus 5 cos square upon cos square x, right? So we divide by cos square x. Then see, numerator 1 upon cos square is sec square x upon, here separate the base, so 3 upon cos square means 3 sec square plus 2 sin square upon cos square means tan square plus 5 cos square upon cos square means 1. Okay, then dx. Then what is the next step? Yes, yes, see this one, sec square upon, now second step is what? Replace the sec square from denominator by 1 plus tan square. So replace sec square, न्यूमरेटर का रिप्लेस नहीं करना है, सिर्फ डिनोमिनेटर का रिप्लेस करना है, sec square को रिप्लेस करना है 1 plus tan square से. So 3 into 1 plus tan square plus 2 tan square plus 5, right? So after simplification what we get, see here, 3 into 1 3 plus 3 into tan square 3 tan square plus 2 tan square means 3 plus 2 5 tan square x plus 3 plus 5 means 8, right? Now this is the actually this case. Now what is the next step? See, next step is substitute tan x equals to t, right? Tan x equals to t. Before that this take common 5, ये हम बाद में भी कर सकते हैं अगली स्टेप में. अगर आप यहाँ पे कॉमन लेते हो तो भी चलेगा, अगर यहाँ नहीं लेते हो तो भी चलेगा, राइट? यहाँ 5 कॉमन लेने का कोई सीन नहीं है एक्चुअली, बट यहाँ इसके बाद हम ले सकते हैं अकॉर्डिंग टू द स्टैंडर्ड स्टेप, राइट? सो अगर 5 ले लिया कोई दिक्कत नहीं है. नाउ 5 by 8, 8 by 5 इज द कांस्टेंट. नाउ पुट tan x equals to t, so sec square x dx equals to dt, right? Then after substitution what we get? See, 1 upon 5 integration 1 upon t square plus 8 by 5. Now this is actually the standard type of integration, but we have to convert 8 by 5 in the square form, right? So 8 by 5 in square form, what we get? See here, 8 by 5 is root 8 by root 5 whole square. Now after considering this is the actually 1 upon x square plus a square, and the integration of 1 upon x square plus a square is what? Yes, integration of 1 upon x square plus a square is what? That 1 upon a tan inverse x by a, right? So you see here 1 by 5, 1 upon a means root 8 by 5, root 8 by root 5, tan inverse x means t upon a plus c, right? So here 5 by root 5 means root 5. Okay, now root 8 is nothing but 2 root 2, right? Because 8 is what? 4 into 2, and root 4 is 2, so 2 root 2 is nothing but root 8, right? So 1 upon root 5 into 1 upon 2 root 2 tan inverse, here denominator of denominator is numerator, so root 5 into t upon 2 root 2, root 8 is what? 2 root 2 plus c. And finally what we get, see here, root 5 into root 2 is root 10, so 1 upon 2 root 10 tan inverse root 5 into tan x upon 2 root 2 plus c. This should be the final answer in this case, right? So in this way you have to solve the examples of this type, and all the three types, the examples of all the three types where you have to solve, and try to complete the try to solve the examples of the exercise also depending on this type, right? I think next is the exercise 3.2, so try to solve the examples of that type, right? and in the next class we see the examples of the another type. You have to practice the examples of the these three types, right, by your own self.